is about a specific project that we did at Flipkart. So just to give people, our foreign visitors here, a bit of context. So Flipkart is sort of like the Amazon of India, and we're right now the largest e-commerce store in India. So let me keep the numbers for later. So in 2011, around about in December, we had a kind of a moment where we realized that our supply chain was not going to be able to scale. We were having very, very serious problems with actually having teams actually building new features. It was going very slow. The number of requests hitting our website were just going through the roof, and we were not able to keep up. So at that point, so let me just actually talk about what the system looked like. So this was version 2 of our supply chain at Flipkart. Version 1, which was kind of written in 2007, was written by our founders, Sachin and Binny themselves in PHP. So this was version 2, which was written in about 2010. It was a open source ERP system called OpenTaps, which we had extended extensively, and was basically a single monolithic application. It had all these modules for order management, warehousing, so on and so forth, and they all ran in a single JVM, connected to a single database, and that was just horrible, right? The problem was that each module, as we were extending it, the developers didn't actually bother to kind of think about, should we be accessing this data, this table, should we be querying it or not? They would just go and make joins across tables to just solve the problem, get the feature out, right? You're probably familiar with that. So horrible coupling, and we spent about a month trying to see if we can carve out each piece from the system and kind of start breaking out services, and we couldn't do it. It was just impossible. So at that point, we took a hard decision that, let's actually rewrite. And this was something which was completely against my ThoughtWorks philosophy of, let's refactor incrementally and go slowly and have the system running and then kind of migrate. But we took this call, and in 2011 December, we started a project so this was sort of a bet the company project for Flipkart. It was so critical at that point that Sachin, who's the founder, actually came and sat with the team. So we basically carved out a team of initially 10 people, and then that increased to about 30 developers. And we moved that team out to a separate office, which was basically a house in Koramangala, which was the place where Flipkart was born. And that was turned into a Skunkworks startup project within Flipkart, where this team worked. And complete isolation, no interviews, no meetings, nothing. This team was only had to build out this system in 7 months, because the next milestone was the Diwali. So Diwali is the time when we do the most sales in the year, and that was in October 2012. So we had about 7 months to replace an entire supply chain system with a new system built from grounds up, get it in production, make sure it's working and it's scaling right. So we had to probably do it by August. We had given ourselves time till August to kind of do that. So we started off on this project, and the idea was to break up each of these modules into services, and I think Chad's talk really set up the context beautifully for this talk, because a lot of the ideas and thought processes that he mentioned is stuff that we've tried to kind of work on and kind of implement in the system. So some of the things we wanted to do was, I think there's a nice phrase called small pieces loosely joined, which I come across around that time. And I think that beautifully summarizes what we want to get to, right? Each service doing one small thing. So you break out the warehouse module into a separate service, order management into a separate service, accounting module, so on and so forth. We didn't want to go down the microservices architecture way. I'd worked with Fred George earlier, and I'd seen some of the downsides of it, and I didn't actually have a clearer idea of how to work around those downsides at that point in time. So I was kind of wary about microservices at that point, and I would love to actually hear people's thoughts on how that's working out. But anyway, so we want to carve out separate services, each doing one thing and doing one thing well. And each service would have its own database, and nobody could access it except the service, right? You could just access it through an HTTP JSON API, and you will never touch my data, right? My private parts are private. So this is what we ended up with. You probably won't be able to read the thing, so I'll kind of read it out to you. So we ended up with about 25 services. This is just a subset of the services we actually built. You have order management service, then the fulfillment orchestration service, which talks to warehousing service and procurement, which in turn calls to supplier. And this is the whole logistics subsystems. And then you have accounting services, document services. And then you have a bunch of infrastructure services, including this piece at the bottom, which was a messaging system that we ended up building called RESTbus, which I'll talk a little bit about, which kind of addressed the problem of cross-service transaction integrity. So in this picture, the Ruby services were basic. So each service, for example, the order management service, the blue pieces were written in Padrino or Sinatra. Oh, okay, that's okay. Apparently a laser, yeah. Oh, sorry. So yeah, so these are written in Padrino, and they ran on JRuby when we went live. We eventually migrated those to MRI, and I'll go into details about why. So these were the Padrino services, and then the UI pieces were written in Ruby on Rails running on MRI. We also had some infrastructure services running on Ruby. For example, the single sign-on service was, we used CAS and we used Ruby CAS. We built a role-based access system, again in Ruby, and a bunch of other pieces, right? So essentially, we went from monolithic single system to 25 services, right? And this was a massive change. And there were totally about 7 teams which worked on this project, owning 1 or 2 services. Each team had between 4 and 6 developers. Yeah, so that's to just set the context about where we were. So when we started the project in late 2011, we were doing the old system was doing about 20,000 orders a day, 30,000 shipments a day, roughly around that order. And this new system has now survived 2 Diwali peak loads, which includes the latest Diwali, which was in 2013. We did, I think, 100,000 orders and 150,000 shipments, and it's working pretty well. So at the time when we were making this decision, we were kind of selecting the technology stack, and the big question was, what tech stack do we use? So Flipkart traditionally had a lot. So the OpenTab's given the Java stack. So most developers were very, very comfortable with Java. So the thought of actually introducing a new language, a new ecosystem, people were kind of wary about that. Also, there were concerns about performance. But I knew from my experience in the past that performance is not a language issue. It's an architecture design issue fundamentally, right? And there are differences in technologies and languages. I'll talk a little bit more about that in detail. But performance I was not too worried about. So why Ruby then? Excuse me. So the obvious reason is speed of development, right? We had a very, very tight deadline. We had to recreate a ERP system in 7 months. We wanted to move fast, right? So that's obviously one reason. The other reason was, I think this idea of small pieces loosely joined is really powerful. Small code bases are inherently easier to debug, right? Like even if you have the best tools and you have a large Java system, it's hard to work. Even though you have great profilers, great monitoring tools, it's still hard when you are dealing with 100,000 line code base. It's just far more complex than dealing with something which is maybe 10,000 lines or maybe 5,000 lines of code, right? And that code compression that Ruby allows is actually really powerful. Also, I think in the Ruby world, Ruby's secret weapon is not Rails. I think to me, Ruby's secret weapon is Active Record, especially for business applications. I just love it as an ORM tool, and it has its problems, especially in the enterprise space when you are dealing with fairly complex logic. You'll have cases where, so because it lacks what's called an identity map, you can have situations where if you're traversing from a parent object to a child object and back to the parent object, you'll end up with two references to the two instances of the parent object, right? And that's kind of bad. Tools like Hibernate in the Java world actually solve this beautifully. So it has its glitches, but still, as a tool to write business applications, I think it's really amazing. So we want to use the power of Active Record. We want to have small systems, which is why we built our services, backend services, which were the HTTP JSON ones, only in Sinatra. And so Padrino was just a thin wrapper around it. So it's Sinatra and talking to its own database. All right. So, okay. So I'm going to kind of try and focus a lot more on the lessons learned. So I'm kind of going to be jumping topics a bit, and there might be a bit of discontinuity, so please excuse that. But I want to kind of get the real key insights that we had on the project out than worry about a kind of consistent flow. So JRuby, right? When we started off, so JRuby is incredible. It's an amazing piece of technology, great community. You get the power of the JVM, which is just amazing. And specifically within the JVM, what you want is its garbage collector and the just-in-time compilation that it provides, right? Those two are just amazing. I'll share some numbers about how those two things actually make a difference, but that's the good part of JRuby, right? Amazing ecosystem. You get all the tools that are in the Java world just work, well, not just work, but they work okay with in JRuby context. But still, you get a lot of tools, libraries that can be reused, etc. The bad. So, what's bad about JRuby? One thing that gets talked about a lot is its slow startup time, and it is a massive issue. Typically, when you're kind of coding and particularly when you're testing, you want to have a very quick cycle of going from test to code and test to and back and forth. But that's hard to do with JRuby. And there are alternatives. You can use things like pre-forking servers, like using Nailgun, for example, or Spork, to actually pre-fork a VM and then connect to it and run tests against it. So all that is fine, but it's still very sluggish to work with, right? So you end up having to kind of jump through hoops to work around that problem. For example, we ended up writing, so all our development was in CRuby. So tests ran very fast, specs ran fast, scripts ran fast. But we would deploy to JRuby. But even there, even for CI and for deployment, you would end up actually writing kind of scripts which were launched in CRuby, but they would in turn just launch JRuby just for the pieces which actually required JRuby. So you have to kind of do a bunch of these things, which is kind of not great. So, but all this you could kind of live with, right? There's one thing about JRuby which surprisingly isn't talked about so much, which I think is fundamentally a deal breaker, and that's its thread safety. It's actually, it's not actually a JRuby problem either. I just think the Ruby world is still not ready to work on a truly multi-threaded Ruby interpreter, right? Which is without the global interpreter lock. And this manifested in horrible bugs for us. So when you start working at scale, you're getting tons of requests into the system. So these problems typically don't manifest when you're running a small service, and JRuby works fine for that, all good. But you will run into cases where some library was not written with thread safety in mind, and that will just kill you. And it is virtually impossible to debug. So we faced problems with Padrino, where the actual app wouldn't get initialized, and it was just horrible figuring it out. And the problem turned out to be something in HTTP router, which is the gem used for actual route creation. And there's no fix for that. It's been about 1.5 years, and it's still not been fixed. We actually put in a patch to Padrino to actually work around. So we created a rack filter which kind of handholds the initialization process, initializes each VM correctly, and it was just horrible code. So that's one. So HTTP router was one example. There was, sadly enough, even Active Record, right? We were on 3.1.x. So Active Record has got concurrency, has got thread safety issues. And they don't show up, again, in normal situations. They show up at scale, at high load. the connection pool is actually not thread safe. So we had situations where the same connection was being returned to two different threads, and they would end up just messing up the database or that transaction. So essentially what would happen was the transaction would commit, the service would say, okay, 200 all okay, committed. And you would go back and see there's no data in the database. Because the transaction never committed, the connection was basically rolled back at some point, and nobody knew anything about it. No framework knew, Active Record didn't know anything about it, but didn't know anything about it. So this was horrible, and we couldn't figure out, we tried patching, we've actually patched Active Record quite a bit, but we couldn't get that to work. So we actually went live with JRuby in September of 2012. And I think in 3 months after kind of struggling with these issues, we kind of took a call to move back to CRuby. And that was a kind of sad moment because I really, really love JRuby. And there are great stories of people using it in production. Not too many, but yes, there are. And its potential is there, but the problem is the libraries and developers are still not in that Java mindset. Surprisingly, the Java world does this very well. They're kind of constantly thinking about thread safety, but the Ruby world is still not caught up to it. It'll probably get there soon. Yeah. So we moved to CRuby, and that sorted out a lot of our performance issues, or rather thread safety issues. I'll talk about the performance parts actually. I've got a comparison there. Yeah, also besides performance, I'm guessing you're saying, but that wasn't too much of an issue. Okay, so I mentioned this briefly. I'll just touch on it. So what's the problem here, right? So when you have a bunch of services like this, right? When you had a single monolithic application, you can start it, you have a request which comes and kind of touches multiple databases, order management warehouse, and you can run all those database changes in a single transaction. Right? It commits or doesn't commit, everyone's happy, right? All beautiful. The moment you go to something like this, that doesn't work, right? Suppose you have a transaction which, say, called create order, which kind of enters so there's a create order request which comes to the order management system. It basically makes a call to approve that order to the fulfillment orchestrator. And as part of the fulfillment, the orchestrator basically tells the warehouse service that, you don't have this stuff in stock, so I'm going to actually order it for you. So he tells the procurement service that go and order this item. But he also has to tell warehouse that, okay, expect this item. I'm ordering it for you, expect it, right? Now those two things, which is I'm placing the order with the supplier and expect the order, has to happen kind of atomically, right? And has to happen atomically along with the commit of the approval. Okay, it got approved, and I've told this guy to procure it, and I've told warehouse to expect it, right? These three things have to happen at one time. Now this is a really, really hard problem to solve. And it's, so the way you solve that typically is to, in the enterprise world, is to use a distributed transaction coordinator. So most of the J2E servers, for example, do that. They actually have, they kind of implement the two-phase commit. And you can actually have a database, two databases take part in a single transaction over 2 phases, right? So that's one way to do it. The problem with that is that completely breaks service isolation, right? Like now, I've got a distributed transaction coordinator which is going to be sitting somewhere here and coordinating transactions between this database and this guy. And if you remember the original principle, right? I don't want to expose my database, right? I want to expose my service. So it kind of breaks service encapsulation very badly. And that's not the least of the problems, right? The bigger problem is that it degrades performance. It's basically a way to ensure a system doesn't scale. Because, when you have a transaction spanning multiple systems, essentially what's happening is under the hood for each database, the resource manager is acquiring some locks on some rows in the table, and those are now held for much longer time because you've got to go through 2 passes through it, right? So essentially, you end up holding locks on database rows for much longer, which increases contention and reduces performance, right? So then how do you solve this problem, right? So the way you solve it, so then the other option is to actually go in for something like use messaging. You actually send messages to other services, and the push to the message queue and the write to the database has to happen as one transaction, right? So that's another option. But again, you need a distributed transaction coordinator there to kind of manage the 2-phase commit between the message queue and the database. So what we ended up doing was we used. Are you serious? 10 minutes? All right. Okay. So yeah. So we ended up creating a service called RESTbus, which kind of essentially does local transactions and asynchronous relay of messages to actually solve the problem. And I'll talk offline about that in more detail if anybody's interested. So what we learned there though was the power of HTTP as integration glue is just underestimated, right? We end up creating, using messaging systems and we use databases. And why do you need that? Why can't messaging be exposed as a HTTP endpoint? We did that, and actually that had amazing side effects to the overall architecture. And yeah, I can't spend too much time on that. Okay, so performance. So Ruby's performance is often talked about as being sluggish, right? So let's kind of get an intuition for how good or bad that is. Let me ask you a question. If you had a Hello World Sinatra route, right, and you were to pound it with requests, say using Apache Bench or something, what kind of response times can you expect? It's just a hello world, so it's just a get/hello world and just says hello world and returns that. That's it, right? Some guesses of how long that would take. How many? 5 milliseconds? Yeah? So that's roughly, it's about it takes about a millisecond at the 95th percentile, but it takes 9 to 12 milliseconds at the 99th percentile, and the max is around 14, right? If you run the same thing in JRuby, it will take about 2 milliseconds at the 95th percentile, and 99th will be about 5 milliseconds. And max also is actually 5 milliseconds. So it's actually very, very tightly bounded. So that's the beauty of JRuby, right? Because its GC is so good and its JIT compilation is so good that it's able to really optimize pieces of code to give you very, very stable response times, but they're actually worse than MRI. So the benchmarks that talk about JRuby being faster, I've never been able to reproduce those. So anyway, so that's an intuition about. So we also actually ended up getting much higher throughput. So that same Hello World servlet will do about 700 requests per second, versus the JRuby one will do about 550 to 580. However, if you had a Tomcat servlet doing Hello World, how long do you think that'll take? Sorry? Yeah, it'll be roughly in the 50 microseconds. It's about 20 to 40 times faster, right? So that was one of the big arguments that was made against using Ruby. Why should we use Ruby? It's so slow. But the point is this: it's still fine. It's perfectly fine. And that's because most business applications are not CPU bound; they're IO bound. They're basically all just waiting for some horribly slow query to return, right? So and it takes the same time waiting in Java or in Ruby. So so that's why actually IO and managing IO is the most important thing, and that includes things like database calls to external services. Yeah, kind of optimizing that is the first priority of for tuning Ruby apps. So, so given this, we wanted to make sure that all our services were kind of behaving well. So we actually built a tool called Rack Metrics, which basically is a rack filter which hooks into the request cycle, and you can actually add plugins to monitor different parts of the application. So we had plugins for Sinatra's routes, so you can actually get an end-to-end request time. We had plugins which hooked into Active Record and calculated the time for each query, and it hooked into REST client and Thrift clients to basically instrument the time taken for all outgoing calls. So the result was it would not rendering very well, but essentially you could go to any service and ask for its metrics, and it'll tell you all the routes that were defined, all the routes, and how much total time was spent in them, the total count, the average time, min, max, etc. And within each route, if you expanded it, it will tell you the 5 slowest requests for that route. So for example, for this post inventory call, there's a call and it tells you how much DB time was spent, how many REST calls, how much REST calls, the split between different parts of the code. And it will give you a list of all the external calls and database queries made, right? So with this, you could immediately find out, like you're doing something stupid like an n+1 query, or that the call to an external system is actually slow, and kind of optimize. You have your pick list for kind of figuring out what you want to attack first, right? So we'd use this, figure out the slow points, optimize that first. So we also had extensive monitoring through StatsD and Graphite. So Graphite allows you to kind of just push points to it, and it gives you a time series view of the data. And we've got, again, as Chad was saying, like metrics from business down to tech metrics, including CPU and capacity and request response times, number of requests. So with this, we also built a alerting framework which basically monitors Graphite, and you can define, okay, if this threshold is breached for this metric, then send me a mail or SMS. So with these three pieces, we had the monitoring in place to kind of keep a check on our systems. Right, so how do you tune that? Once you kind of figure out the problems that are typically there, it's actually fairly straightforward, right? If it's I/O, fix the I/O problem. Right? If it's n+1 query, remove it, do a eager join, simple stuff. If it's a bad query, run MySQL explain or whatever query plan tool you have for your database. Get the query plan, figure out what's the optimal join sequence, and actually fix the query. For external calls, we actually end up putting in very aggressive timeouts so that you don't have a thread or a process just waiting forever for somebody else to respond, right? Because that has very bad effects on capacity of your entire cluster. Because, for example, if you have a service which is calling another service, and that service is running slow, you can end up completely freezing this calling service because all processes are just waiting for this guy to respond. Right? So once these two kind of things are fixed, then it's important to look at GC itself. Now, Ruby's default GC settings are actually very conservative, and you'll typically see initial, just after restart, response times are kind of slow and they kind of get faster, and they converge pretty fast, but there's still a lag. So there are ways to kind of improve the default heap size and the allocation rate and percentages and all that stuff. I've got a reference to that at the end. But I think that's something which we did, and that immediately improved our response times. So this still doesn't address all problems, right? There are still cases where GC is still a problem. For example, there will be queries which just load a ton of data. Say, for example, reporting queries, right? And those are tricky. So for those, what we end up doing is just carving out a separate cluster. Just earmark two nodes in your cluster for the reporting queries, give it a separate virtual IP or separate VIP, and point all those requests to those servers. Even if that doesn't fix the problem with GC, then you've got to go down to profiling. So for profiling, we end up using perf tools. Again, I've got a link to it at the end, which is a great tool. There are rack filters which kind of can mod the request, hook into the request cycle, and actually give you a graph of the call chains along with how much time was being spent in each section, and that's great. And that will tell you exactly whether time is spent in GC or some section of code. So that's your final kind of hammer you can kind of use to address performance issues. We also ended up playing around quite a bit with changing app server. So we moved from Trinidad in the JRuby world time to in MRI we used Passenger first, and then now we're on Unicorn. And Unicorn particularly has a plugin called the out-of-band GC, which basically runs GC on that. It basically disables GC for that particular interpreter and runs GC after the request cycle ends, right? So none of your requests actually see bad response times or due to GC. So that works beautifully, actually. It's a really nice plugin. There's also a plugin called Worker Killer, which can kind of kill a worker at when it crosses a certain memory threshold. So we use all these. Okay, so this is another problem that we faced, which was we now had 24 or 25 services running Sinatra and Padrino apps, and there was a bunch of Ruby gems that we were using, which are the core platform gems which had to be shared. And each team worked independently, so it ended up becoming a problem for the platform team to kind of go and chase around people saying, okay, upgrade this gem, otherwise no, there's going to be problems. And that was a big issue. So what we ended up doing was creating a patched version of Bundler, which essentially allows you to annotate your gem file or each gem line with a auto update equal to true flag. And then Bundler basically will, when you run bundle install, it will basically check if there's a new version of that same gem in the repo and actually resolve all its dependencies and actually install that. So the nice thing about this was it works in the devs environment. It's not something which happens automatically in the background. You're going in kind of messing around with platform gems. And it happens frequently enough that everybody, the entire ecosystem kind of moves together and upgrades the services quickly. Okay, so can I take 5 moments? No? All right, okay, I'll rush through. So, okay, team dynamics. So we started with the Java team, and we kind of just threw them into the deep end on into Ruby, and we just had about 2 or 3 Ruby devs. So it took, on an average, I think, people about 3 to 4 months to start writing idiomatic Ruby, and that was a big challenge. So we did a bunch of things to kind of address those problems, including kind of having consultants to pair with people on the team, having one expert per team, etc. Okay, I'll skip to, all right. So one of the things that we noticed or happened was that because Ruby is such a dynamic language, you can write such code so quickly and so compactly. Sometimes it tends to, design tends to be taken for granted. I don't know if it's automatic or not, but I feel it tends to be taken for granted. Like devs don't think that, okay, here's a feature, let me just add it quickly because, yeah, Sinatra, just add a route, I'm done. But I think this is the really big problem because you end up, or rather you need to actually ask very deep questions about the domain. And we actually got caught in this problem a couple of times where we actually ended up creating small custom solutions to specific problems instead of asking deep questions about, okay, what is this domain, what is this problem really about? What is warehousing, for example, really about? It's not about pick lists and put lists, it's about goods movement and material movement, and how do I model that as a first-class concept, right? And I wonder if Ruby being a dynamic, powerful language actually contributed to that. So anyway, that's more a question for me. Okay, yeah, questions. The slides, so there is a bunch of references at the end, but yeah, and if you want to take questions.
Sorry, Yogi, no questions.
All right, no questions. All right, sorry. Thank you, guys.
Thanks for the insights, Yogi.